Hello and welcome to the May RCA Institute webinar and discussion. My name is Larry White. I'm Executive Director of the Resource Consumption Accounting Institute. This webinar will present a Siemens video about MOM, MOM-proEO and MindSphere Joint Solution. I'll explain those in a minute. For automating the analysis and response to an operational manufacturing event by integrating operational and financial systems and information. The focus is on the RCA-based managerial costing model. For those of you who are non-manufacturers, let me just give a few of the definitions or the terminology may confuse you. MOM or MOM is Manufacturing Operations Management Software. ProEO is a software that supports an RCA model of operational resources, processes, and costs. And you'll hear MindSphere mentioned quite often. MindSphere is a software that connects the Internet of Things within a manufacturing environment, primarily sensors. And finally, just for anybody, opportunity cost is the cost of options or decisions not taken. This is a somewhat promotional video for Siemens and their partners. So I do need to ask you to look beyond the specific solutions and focus on the functionality being achieved. I think you'll find it interesting. Altavia, one of the partners in the video, is an RCA Institute member and sponsor. I'll stop the video from time to time to make comments, and then at the end of the presentation, again, I'll take everybody off mute for your comments. I'm going to leave the presentation in this, not in presentation mode, because that way I can see the progress of the video, and that allows me to stop at the right points. If I do it the other way, it's likely I'll make a mistake, and that will be more distracting, me trying to keep track of the time. So please bear with me, especially if something strange pops up on my screen.
This joint solution is based on an environment developed on top of Somatic IT, Siemens PLM MOM software, MindSphere, Siemens Industrial IoT platform, and ProEO, a real-time financial value provided by the extension of manufacturing operation to IoT for sophisticated analysis algorithms integration, and to financial to provide real-time insight on the cost of operations, suggesting the application of a specific manufacturing scenario versus others. MindSphere, interacting with IoT, detects an anomaly on a motor and passes this information, combined with other contextualized data, to suggest two maintenance alternatives. ProEO uses historical maintenance cost data and proposed resource usage to value the maintenance scenarios and presents the financial information to the user. When the user selects one maintenance scenario, in particular the most cost-effective one, ProEO notifies MOM, which creates a maintenance order that will be scheduled with pre-actor. This use case provides the basis to show the potential possibilities of integrating the world of Somatic IT MOM with the world of ProEO and MindSphere. Somatic IT executes the operations on the shop floor and is able to access an extensive amount of data enriched by manufacturing context. ProEO provides accurate financial analysis based on real-time manufacturing data, while MindSphere finds smart ways and new approaches to solving real-world challenges.
All right, let me pause just for a minute. I want to emphasize that ProEO is an RCA model. Being an RCA model, it is first and foremost designed as an operational model. Then cost collection is structured to ensure that the data and the costs collected reflect the operational model and the operational quantities and scenarios that are occurring. Many traditional management and cost accounting models are purely financial models and distort or misrepresent the details of operations and the use of resources with highly generalized allocations and assumptions. Also note the emphasis is on supporting real-time operational information, and we'll talk some more about that as we go through the video.
Leveraging strategic alliances is crucial in order to realize the value to the customer, provide the required competencies and skills needed to successfully consult, and support the end user throughout the transformation process. Siemens' major goal is to provide value to its customers, and for this reason, Siemens created MIAC, an ecosystem of strategic alliances devoted to manufacturing customers who need efficiency in owning MOM. Altavia Consulting is a Siemens PLM software MIAC alliance and joined this group to help bridge the gap between the shop floor and the top floor by integrating operational information with financial and cost information, enabling a clear cause and effect model for decision makers.
So I want to stop with the cause and effect because that's particularly important to RCA. RCA costing focuses on reflecting causal, operational, resource, and process relationships with cost information. You may remember from some of the other presentations, we focus on an operational model that is then costed. The emphasis is on reflection. This means that the decision makes sense from both an operational and a financial perspective. The information is designed for internal decision makers. This is different than traditional financial and cost accounting metrics because that information is really designed for external investors and creditors and infrequent historical reports. Shoot, sorry, I lost my place. I'm gonna have to.
This joint solution is a global company that provides the Digital Enterprise Software Suite, a solution for the digitalization challenge of manufacturers. The Digital Enterprise Software Suite integrates and digitalizes the entire value chain, which is key to staying competitive in the future. Altavia Consulting was formed in 1998 as a niche provider specializing in advanced cost management directed at strategic solutions. Altavia optimizes efficiency and ultimately profitability by providing financial insights into production alternatives, supply chain options, product mixes, customer campaigns, and channel expansions. Altavia brings all of these concepts together with advanced technology know-how to deliver state-of-the-art solutions for superior analysis and optimized decision-making.
Now, in the next section, this is just a short interruption, there's going to be some discussion of a scenario. The scenario was at one point, I'm not sure if it still is, an actual physical setup that did exist and could be examined by people that were interested in seeing it and prospective customers.
This joint solution is applied in a conveyor scenario that shows the execution of manufacturing operations, the integration with PLM, automation, ERP, and third-party systems and devices. MindSphere provides the extension to IoT, while ProEO shows the financials. Through a few workstations, it is possible to show a test operation, an assembly operation, and also MindSphere and ProEO functions. This joint solution is leveraging the Siemens product portfolio, in particular MOM and MindSphere, and Altavia's flagship product, ProEO. The demo is based on a simplified use case that provides a proof of concept for the potential capabilities of this integration. An IoT sensor is feeding MindSphere with vibration measures of a motor. This sensor shows a spike in the measure, and MindSphere detects it, generating a message to ProEO. This is a simple use case, but it can be enriched with further actions from MindSphere. For example, cross-checking the vibration measure with temperature and torque data in a specific algorithm and propose a narrower list of solutions. ProEO then uses the information from MindSphere and, leveraging the input of the maintenance team, evaluates 2 maintenance scenarios, providing insights to maintenance users to take the decision about which scenario is best from a financial standpoint.
So just a quick pause again. Obviously, there are more than 2 possible scenarios and solutions to any given problem that you see like this. All of the softwares involved, ProEO, the RCA software, and the operational softwares from Siemens are capable of handling much more. So, like I say, this was just the demonstration.
The selection of the most economic scenario will cause ProEO to trigger the creation of a maintenance work order in MOM. MOM will use pre-actor to schedule and dispatch said order. This demonstration shows the potential of transparently integrating different tools, MOM, IoT, and financial, leveraging sophisticated algorithms and data analysis tools, and using the powerful financial model to define and apply manufacturing strategies. A perennial goal of every manufacturer is to improve efficiency by increasing asset uptime. Equipment downtime can be extremely costly, making it critical for maintenance to be proactive rather than reactive. Downtime is a major factor that limits the ability to achieve optimum manufacturing efficiency. It leads to a stop of the manufacturing process and creates a cascading effect that disrupts the entire workflow. Technology enables managers to determine when a piece of equipment will fail.
So just a quick stop here again. Most costing systems, most traditional costing systems, don't create sufficiently detailed, reflective, or timely information to support real-time operations like you're seeing here.
Before it does, once it is determined that a certain device may fail in the short term, then it becomes even more critical being able to minimize this impact. IoT solutions in industrial environments can lead to the development of innovative and efficient systems aiming at increasing operational efficiency in a new generation of smart factories. This joint solution shows a somatic IT MOM application working with MindSphere to seamlessly integrate condition-based maintenance with product scheduling. This solution can be implemented in different industries, including food processing, manufacturing, and other verticals. It also shows the value of integrating somatic IT MOM data with a real-time financial tool such as ProEO to generate real-time decision support information that shows the financial impact of choosing one maintenance approach rather than another. This approach promises cost savings over routine or time-based preventive maintenance because tasks are performed only when they are needed.
So RCA was identified as providing a particularly solid foundation for creating real-time information to support financial systems and the decision-making that they need.
Following the best and most cost-effective scenario. This solution features tight integration between MOM, MindSphere, and ProEO. This integration is key because it shows the power of the combined solutions, manufacturing execution, Internet of Things, and financials. MindSphere uses data coming from various sources, including IoT, to perform intelligent data analysis, cross-checks and executes complex algorithms to identify hidden paths, and ultimately, identify anomalies in the behavior of some component. The power of the integration is shown as MindSphere is able to reach back out to MOM with this information that activates the core engine of a MOM system that is able to execute processes and workflows. In this demo, an IoT device is collecting vibration data of a conveyor line. Vibration data is seamlessly shared with MindSphere in real time. The self-learning anomaly detection module of MindSphere will send out an alert in case abnormal vibrations are being detected. Manufacturing execution generates operational data that can be used to feed the financial model in ProEO. The ProEO software contains the plant operational model, including all resources, people, machines, facility, etc., and all products, bills of material, and bills of process. As a consequence, ProEO can ingest the decision alternatives derived from the real-time data into its financial model, allowing it to compare alternatives and enabling users to select the most appropriate option from a financial standpoint. In the end, with ProEO, the user can understand what will be the economic costs of choosing one alternative over another. Thus, the user is enabled to select the optimal and most cost-effective approach to solve a maintenance problem.
It isn't mentioned here, but the other point of this scenario was to see if the information from ProEO and the capabilities of the Siemens products could form a basis for artificial intelligence for certain types of decisions, either making them or presenting them with just flat out decision options.
Here we are showing the stream of data shared from an IoT device with MindSphere. For obvious reasons, the example is relatively simple, but you can imagine that MindSphere can collect and correlate different data from different sources to perform sophisticated analysis at virtually any level of complexity. In this case, MindSphere can apply algorithms and rules or run the data against inputs coming from other systems and discover crucial paths in the production for which it turns out to be essential to send a notification to the MOM system. Specifically, MindSphere detects the warning condition and alerts MOM, ProEO, and maintenance. Maintenance personnel and the line supervisor then, leveraging ProEO, define possible maintenance scenarios to overcome the anomaly. Two possible courses of action are predefined in ProEO for this particular vibration anomaly.
So just a quick stop here. So there are maintenance people involved or some sort of experiential system data that's available. And this can inject probabilities into the mix. And that wasn't done in this scenario, but you know, there may be what's the probability of waiting to the end of the shift, watching continuously the rate of deterioration and seeing if the probability of a failure increases, or you know, the probability of a failure not occurring until the next job changeover. So there are some other possibilities here that could be injected into a more complex scenario.
1. Stop the conveyor and repair the track causing the vibration. Maintenance department provides parts cost and resource time needed, and ProEO adds the opportunity cost of downtime. Or 2. Operate the conveyor until it fails and repair it at that point. ProEO has history on maintenance events for conveyor replacement and adds the opportunity cost for a longer downtime. The power of integrating ProEO becomes apparent as the financial impact of each corrective option is presented to the maintenance personnel and line manager. Armed with the financial information provided by ProEO, they are able to choose the most economical solution.
Okay, so I just want to mention opportunity cost, since it was mentioned a few times there. Opportunity cost is a fairly complex transaction or piece of information. It involves not just what happens, but data that can be confidently extended to scenarios that haven't happened. RCA models can create this kind of information in the needed level of detail for real-time decision making, and with characteristics such as fixed and proportional resource impact and resource cost characteristics at very discrete, particularly resource group output levels, not just at the final product or final output level. Costs are tightly connected to various operational and capacity use scenarios with RCA.
Once the loop among MOM, MindSphere, and ProEO is closed, MOM can leverage predefined workflows to react to the ProEO notification. MOM generates a maintenance work order to fix the conveyor to be scheduled when possible after the current production run ends. The work order is sent to pre-actor for scheduling or dispatching. The interesting aspect is that once MindSphere and ProEO are participating in the workflow, a wide range of opportunities and the economic value of each becomes available. One example of an opportunity is that MindSphere could provide feedback to one plant based on inputs received from another plant. MindSphere could also receive notifications from the plant and close the loop with the supply chain. Opportunities are countless, and the flexibility of this approach enables the definition of and support for more sophisticated manufacturing strategies with the ability to compare the economic value of each. Understanding the sophisticated manufacturing strategies available and their financial impact provides added value to customers. The benefits derived from a preventive maintenance tool are not only linked to the ability to optimize the production, but also to a better organization and management of the work, as well as reducing the cost of the maintenance activities to a minimum. Major benefits provided are improved plant uptime, extended lifetime of equipment and parts, facilitation of maintenance teams' work, optimal production execution, reduced costs and improved efficiencies, increased return on assets. This solution shows how integrating three highly sophisticated environments such as MOM, MindSphere, and ProEO results in the ability to provide high-performance solutions to enhance manufacturing operations to both current and future customers.
Okay, thanks for listening to that. I hope you found it somewhat interesting. I know it is a little bit repetitive, but I think it presents some good points. The critical takeaway is the benefit to a productive process of having reflective, cause and effect monetary information available in real time. That can be used to compare detailed resource and process scenarios to ensure the most economically beneficial action is taken by people deep inside the organization, not just up on the top floor. RCA models create information that is this capable. This is extremely uncommon for most financial reporting focused cost accounting systems, and traditional systems really can't be extended to meet this challenge. Why? RCA models are designed with causality as the core principle. Most financial models, excuse me, put external financial reporting standards as their core principle. They are not designed for internal decision support and really don't do it very well. RCA is designed for internal decision support, and that's what it does best. So let me take everybody off mute and see if there are any questions. I wanted to open it up for any questions from anyone. I'm going to take it off record.